Estimating branch circuit wiring in commercial structures can be streamlined by using a unit length method for conduit and cable. Assign a standard length, such as 50 feet, to each device or fixture. Multiply this length by the number of devices or fixtures to estimate the total conduit or cable length. It's important to consider the building layout, accounting for horizontal and vertical runs, as well as obstacles like walls, ceilings, and partitions. Always add a buffer of 10 to 15% for waste and contingencies, which will allow for extra material to accommodate unexpected route changes or potential damage. For junction box estimation, a good starting point is to estimate one junction box per 150 to 200 square feet of floor area. Consider device spacing, placing junction boxes at convenient intervals, such as 4-foot centers, to minimize conduit lengths and wire splices. It is also wise to allow for future expansion by providing additional junction boxes and conduit space for potential device additions or upgrades. To improve efficiency, consider electrical design software to automate the estimation process and provide accurate quantities. Breaking down the project into smaller areas, such as estimating one level or section at a time, can help prevent mistakes and reduce errors. If you have worked on similar projects in the past, referring to those previous estimates can be a helpful guide. Consulting with a licensed electrician can provide expert advice and help you refine your estimates. Using estimating templates that include standard quantities for typical devices and fixtures can also save time. Remember to share your estimate with others, such as project managers and engineers, for review and feedback. When estimating, consider the lighting power density in watts per square foot based on the building type and usage. Ensure your estimate meets the requirements of the National Electrical Code, known as NEC, and any local codes. Calculate voltage drop over the entire circuit to avoid excessive voltage loss. Do not forget to consider the power requirements for ventilation fans, air handlers, and other heating, ventilation, and air conditioning equipment. Account for any specialty lighting systems, such as track lighting or fluorescent fixtures, as well as security systems or data infrastructure. Now let's dive into some more specific areas to refine the estimating process even further. When considering conduit runs, think about the type of conduit that will be used. Electrical metallic tubing, known as EMT, is common for exposed runs, while rigid metal conduit, known as RMC, might be necessary for areas where there's a risk of physical damage. The choice of conduit will affect both the material costs and the labor involved in installation. Cable type should also be carefully considered. For example, metal-clad cable, known as MC cable, is often used for branch circuits in commercial buildings, but the specific type of MC cable needed might vary depending on the application. Is it in a plenum space? Does it need to be rated for direct burial? These factors will influence the material selection. Let's consider wire sizing. This is crucial to comply with the NEC and prevent overheating. The wire gauge must be adequate for the anticipated load, taking into account factors like ambient temperature and the number of current-carrying conductors in a raceway. NEC Table 310.15b16 is essential for determining ampacity. Remember to factor in dating if multiple conductors are bundled together. Another important consideration is the accessibility of junction boxes. NEC Section 314.29 requires that junction boxes be accessible without removing any part of the building structure or finish. So you need to plan for the placement of junction boxes accordingly. For lighting circuits, consider the use of lighting control systems such as dimmers or occupancy sensors. These can reduce energy consumption, but they also add complexity to the wiring and require careful planning. When estimating the number of devices, don't just count the visible devices. Think about receptacles behind appliances or equipment that might not be immediately apparent. Also, consider spare capacity for future needs. It's often wise to add a few extra receptacles or spare circuits to accommodate future equipment additions. Grounding is another critical aspect. Ensure that the grounding system complies with NEC Article 250. This includes proper sizing of grounding conductors and ensuring effective grounding and bonding of all metallic parts. For multi-story buildings, vertical conduit runs require careful planning. Consider the use of cable trays or vertical supports to manage the weight of the conductors. Also, remember to provide adequate access for pulling conductors through long vertical runs. When estimating labor hours, break down the project into discrete tasks. For example, estimate the time required to install conduit, pull wire, terminate devices, and install junction boxes separately. This will give you a more accurate overall labor estimate. Don't forget to factor in time for inspections and testing. Electrical inspections are typically required at various stages of the project, and time must be allocated for these inspections. Also, allow time for testing the completed installation to ensure that it meets all applicable codes and standards. When estimating the cost of materials, get quotes from multiple suppliers. Prices can vary significantly, so it's worth shopping around to get the best deals. Also, consider the lead time for materials. Some materials might not be readily available, so it's important to factor in lead time to avoid delays. For large projects, consider using a project management software to track costs and progress. This can help you stay on budget and on schedule. 1. Remember to keep accurate records of all changes to the design. Change orders can significantly impact the cost and schedule of the project, so it's important to track them carefully. 2. Establish a clear communication plan with the other trades involved in the project. Coordination with plumbers, HVAC contractors, and other trades is essential to avoid conflicts and delays. 3. Consider the impact of the project on the building's occupants. If the building is occupied during construction, it's important to minimize disruptions and ensure the safety of the occupants. 4. Develop a safety plan for the project. Electrical work can be hazardous, so it's important to have a plan in place to protect workers and the public. 5. Before starting any work, verify the existing electrical system. This includes identifying the location of existing circuits and ensuring that they are properly labeled. 6. Use appropriate personal protective equipment, PPE, such as gloves, safety glasses, and insulated tools. 7. Always de-energize circuits before working on them. Verify that the circuit is de-energized using a voltage tester. 8. Follow all applicable codes and standards, including the NEC and local codes. 9. If you're unsure about something, ask for help. Don't take risks that could jeopardize your safety or the safety of others. 10. Document everything. Keep accurate records of all work performed, including wiring diagrams, test results, and inspection reports. Let's discuss voltage drop calculations. Voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 210.19 AM provides guidance on voltage drop limits for branch circuits. The NEC recommends a maximum voltage drop of 3% for branch circuits and 5% for feeders plus branch circuits. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the direct current constant, typically 12.9 ohms for copper and 21.2 ohms for aluminum. I is the current in amps, D is the one-way distance in feet, and Cm is the circular mil area of the conductor. Using this formula, you can determine the appropriate wire size to keep the voltage drop within acceptable limits. It's also important to consider the ambient temperature when selecting conductors. Higher ambient temperatures can reduce the ampacity of conductors, so it's necessary to dare the conductors accordingly. NEC Table 310.15b16 provides ampacity ratings for conductors at various temperatures. For example, a number 12 copper conductor might be rated for 30 amps at 30 degrees Celsius, but its ampacity would be reduced at higher temperatures. When estimating the number of outlets, consider the type of equipment that will be used in the space. For example, offices typically require more outlets than storage rooms. Also, consider the requirements of NEC Section 210.52, which specifies the spacing requirements for receptacles in dwelling units. Although this section applies to dwelling units, it can provide useful guidance for spacing receptacles and other types of spaces as well. In addition to receptacles, consider the need for dedicated circuits for equipment that requires a lot of power, such as computers, printers, and copiers. Dedicated circuits can prevent overloading of general-purpose circuits and ensure that equipment operates reliably. When estimating the size of panel boards, consider the number of circuits that will be required, as well as any spare capacity that might be needed for future expansion. Also, consider the physical size of the panel board and ensure that there is adequate space to install it. When estimating the cost of labor, consider the skill level of the electricians who will be performing the work. More experienced electricians can typically complete tasks more quickly and efficiently, which can reduce labor costs. Also, consider the prevailing wage rates in your area. Prevailing wage rates are the minimum wage rates that must be paid to workers on public works projects. When estimating the cost of permits and fees, contact the local building department to determine the required permits and fees. Permit fees can vary depending on the size and complexity of the project. Finally, remember to review your estimate carefully before submitting it. Check for any errors or omissions and make sure that your estimate is complete and accurate. A well-prepared estimate can help you win the project and ensure that it is completed successfully. And in case a commercial building is involved, here are some additional points worth noting. First and foremost, when estimating for commercial structures, understanding the specific occupancy type is critical. For example, an office building will have different electrical requirements than a restaurant or a retail store. These requirements will dictate the types of lighting, receptacle placement, and special equipment circuits needed. For instance, restaurants require specialized circuits for cooking equipment, refrigeration units, and exhaust systems, whereas retail stores often have extensive lighting and display case power needs. Secondly, consider the building's construction type, which greatly influences the choice of wiring methods. Concrete structures may require conduit to be embedded within the concrete, adding complexity and cost to the installation. Steel-framed buildings might allow for more flexible wiring options like cable trays or MC cable. Thirdly, the Americans with Disabilities Act, known as ADA, has specific requirements for the placement of receptacles, switches, and other electrical devices. These requirements must be carefully considered to ensure compliance. For instance, the maximum height for switches and receptacles is typically 48 inches above the finished floor. Fourthly, energy efficiency is a significant concern in commercial buildings. Lighting control systems, such as occupancy sensors and dimming controls, can reduce energy consumption and save money. These systems should be considered in the estimate. Fifthly, emergency and standby power systems are often required in commercial buildings to provide power during outages. These systems can include generators, uninterruptible power supplies, ALPS, and emergency lighting. The cost of these systems should be included in the estimate. Sixthly, fire alarm systems are essential for life safety in commercial buildings. These systems include smoke detectors, pull stations, and alarm bells. The cost of the fire alarm system should be included in the estimate. Seventhly, data and communication systems are becoming increasingly important in commercial buildings. These systems include telephone, internet, and data cabling. The cost of these systems should be included in the estimate. Eighthly, security systems are often installed in commercial buildings to protect against theft and vandalism. These systems can include surveillance cameras, alarm systems, and access control systems. The cost of these systems should be included in the estimate. Ninthly, consider the phasing of the project. Larger commercial projects are often phased, which can affect the sequencing of the electrical work. It's important to coordinate the electrical work with the other trades involved in the project. Finally, remember to factor in the cost of project management. Larger commercial projects require careful project management to ensure that they are completed on time and within budget. And to recap, estimating branch circuit wiring for commercial structures involves several key steps. 1. Accurately count all devices and fixtures. 2. Use a unit length method to estimate conduit and cable runs. 3. Account for horizontal and vertical runs, as well as obstacles. 4. Add 10 to 15% for waste and contingencies. 5. Estimate 1 junction box per 150 to 200 square feet of floor area. 6. Consider device spacing to minimize conduit lengths and wire splices. 7. Allow for future expansion. 8. Utilize electrical design software to automate the estimation process. 9. Break down the project into smaller areas. 10. Leverage past experience from similar projects. 11. Consult with a licensed electrician for expert advice. 12. Use estimating templates to standardize quantities. 13. Allow for review and feedback from others. 14. Estimate lighting power density. 15. Ensure compliance with the NEC and local codes. 16. Calculate voltage drop to avoid excessive voltage loss. 17. Consider power requirements for ventilation and heating, ventilation and air conditioning systems. And 18. Account for any specialty lighting, security, or data systems.